Alright, so here's a brief video to attack the problem that many beginning chemistry students have, and that's how to generate the formula for ionic compounds in particular from their name. So the first case, sodium chloride, well, we have sodium, which is in group 1, and therefore we'd expect to form a +1 ion. And then chlorine, which is in group 7A or group 17, so it's just one away from that noble gas, so we'd expect that to form a -1 ion. And so one of the tricks that we sometimes use is we look at the charge on the cation and the anion, and we'll swap them. So the charge on the anion without the minus sign and the charge on the cation without the plus sign will become the subscript. So in this case it would be Na1 Cl1, which we would not show the ones to get the formula, the accepted formula of NaCl. Okay. Things get a little more complicated with our next example, magnesium iodide. So we have magnesium being in group 2 would form a +2 ion, right? It's going to lose 2 electrons to form the noble gas configuration of neon, the noble gas that precedes it. And then we have the iodide ion also in group 7A or group 17, so it's going to be a -1, just like chloride. And now when we swap them, we have the 1 and the 2, and so we swap them over, and we get a value of Mg1 I2. And just like up top, we wouldn't show the 1 for the magnesium, we would keep it for the iodide, and we would get a formula of Mg I2 overall. Okay, so far so good. So if we look here at the cases involving the transition metals or some of the lower members of the main group like lead, as we'll see here, these will have numbers in there. And again, the number in the Roman numeral indicates the charge on the metal ion. So for copper 1 sulfate, what that 1 tells us is that we're dealing with Cu +1. Sulfide being coming from sulfur, being the ion that sulfur makes, sulfur being in group 6A or group 16, will form a -2 ion. It'll gain 2 electrons to become like the noble gas that follows it. And so when we swap these charges without the signs, we'll end up with a case of Cu2 S1, which again, we ignore any 1s to get the overall value of Cu2S. So that 1, copper 1 sulfide, doesn't tell us the subscript, right? The subscript's very clearly a 2, but beginning students will often make that mistake. They'll confuse the subscript with the Roman numeral. The Roman numeral tells us the charge, and then by comparing the charges and getting a neutral overall compound, we arrive at the correct formula. If we look at our last example here, lead 2 nitrate, it's even more complicated because nitrate's one of those polyatomic ions. So the lead 2 tells us that we're dealing with the Pb2+ ion. The nitrate ion, it's just one of those you're going to have to memorize. NO3 -1. So as we swap those values without the charge, we arrive at a formula of Pb1 NO3 2. Now the rule with the polyatomics is when we have more than one of them, we need to indicate that with brackets. Okay, and obviously we don't show any subscripts of 1, so what we really have here is Pb NO3 2. Okay, so hopefully this little exercise has made you a better student at arriving at the formula of an ionic compound from its name.